Sometimes I really love the website Math Stack Exchange because it leads to really creative and interesting discussions. Here's a thread from over 5 years ago where somebody was saying, hey, I have a group and suppose I know the order of it is n factorial. Does it have to have a subgroup of order n? Like leave the factorial off. And this user who posted the question kind of said what they knew, and there was some interesting initial discussion. In fact, the original poster got a little impatient and wanted to accept an answer before people had a chance to think about it. And if you keep like looking down the page, like people really thought about it. Like this person like thought about it and gave a partial answer, right? They did some cases where n is like one of those 4 numbers. They did a lot of work, and this is all original math. Like this is not like someone looked something up in a book. This is somebody working hard to just help some stranger on the internet with a pretty tough math question. So what is this question really even about? Well, it's about something in math called a group, which you should think about as like a set of symmetries. So for instance, if we look at this hexagon here, we can say that maybe it has rotational symmetry or reflectional symmetry. And we might want to think about some of those symmetries in isolation or together, and we might want to count how many total symmetries there are. And so suppose I have an object that were to have, I don't know, 12 symmetries. I might ask if there's a smaller set of them that would themselves form a group of symmetries. And so if I have 12, like maybe is there a subgroup that could have exactly 7 elements or exactly 8 elements? And when you learn group theory in an abstract algebra class, you'll learn that there are like definite rules about what is possible and what's not possible. For instance, one of those theorems is something called Lagrange's theorem, which says that if you have a subgroup, then the size of the subgroup has to be a factor of the size of the big group. And so in our first example, when I said I had a group with 12 elements, you couldn't have a subgroup that had 8 or 7 elements, but you might have a subgroup that has 6 elements, or you might have a subgroup that has 4 elements. Now, Cauchy's theorem provides kind of a better answer than that by saying if you're looking for a factor that's prime, then it guarantees that there will be a subgroup of that size. And so if you have a group, say, with 24 elements, that would be 4 factorial. Well, then since the prime number 3 is a factor of that, you definitely have a subgroup of order 3. But it doesn't necessarily say anything about maybe a subgroup of order 4. However, there are other theorems you could go. If you look through this page, there's something called the Silo theorems that would actually answer that problem in that case. And when we come back over here, you can read more about the discussion and what people were saying to try and solve this problem. I was just randomly Googling because I was curious about what was known about these groups, and I was frankly pretty surprised to find out that this fairly basic question, I think, is still open. There are lots more sophisticated ones that I wanted to ask, but even this one is still open, and I think that's what makes math pretty cool.